Hi, this is the Zeta chassis group for MAE 152. The design that our group chose for analysis is an electric race car chassis. The chassis is the internal framework or skeleton which houses all the race car components and keeps the driver safe in impacts. The material used is 4130 tube steel with a 1-inch outer diameter and a 0.87-inch inner diameter. The individual tubes are connected to each other with welds. We did 4 tests consisting of loads on the main roll hoop, front bulkhead, and side impact. Our first test is for the main roll hoop. We have fixed geometry here for our boundary conditions, and loads here. The loads are to simulate the stress the main roll hoop would receive if it flipped. Here's the von Mises stress and displacement. Our second test is for the front roll hoop. We have fixed geometry here, and for our boundary conditions, and our loads here. The loads are to simulate the stress on the front roll hoop if the car flipped over. Here is our von Mises stress and displacement. Our third test we did is for the front bulkhead. We have fixed geometry here for our boundary conditions, and loads here. This is to simulate the front bulkhead crashing into a wall at full speed. Here is the von Mises stress and displacement. Lastly, we have the side impact. There is fixed geometry here, and loads applied here. This assumes that the car crashed at full speed on its side. Here is the von Mises stress and the displacement. For our design iteration, we added additional tubes to the frame from the main roll hoop to the upper side of the impact tube. This was to prevent the chassis from bending upwards in our front impact. Here's our results from our test with the iteration on the front bulkhead. For our second design iteration, we felt that the inner bracing tubes are unnecessary weight and removed them. Here's our results from our test with the second iteration on the side impact collision.